All right. Very good evening, everyone. Good evening, ma'am. So once again, I welcome all of you for the day two session of our workshop, CFA and SEM using AMOS. I request ma'am to kindly please take over the session. Thank you so much.
Thank you so much, sir. Thank you so much. Thank you so much, everyone. Uh, is there any doubt from the session we have done yesterday? If you have doubt, you can ask me now. Otherwise, I will go directly with EFA, how to create the model on AMOS, and then we will go with regression. Like we will perform the SEM analysis. So I just want to ask if there is any doubt, then you can ask me now. Otherwise, I would like to continue with the session today. Okay. So I don't think so that there is any doubt. I would like to continue with the session. Okay, so I'm just sharing my screen. Just give me a minute, everyone, please. Give me a minute. Okay, so I'm sharing my screen. Yeah, is it visible to everyone?
Yes, ma'am.
Yes, okay, fine, thank you. So like what we have seen yesterday, we have ended up after understanding the different level of scales, personification of a variable. We have also seen that when we should have like there is one query which has been raised yesterday during the session that I should focus more upon, like when to use SEM, when to use CFA, what are the different conditions. So before starting the hands-on experience, just keep in mind that your dependent and independent variable should be metric, or the data should be collected on Likert scale, and then we can perform the SEM analysis. We can perform CFA too. We have also seen the reflective questionnaire and formatted questionnaire. So if our questionnaire is based upon the reflection of items into a construct, we can go with AMOS. But if the questions are being like the formation of a construct is based upon the different types of items, then we should go with Smart PLS. Now, I would like to start with the exploratory factor analysis. And I have shared one file with you all. So car sales, right? So if like all of you are able to download that file in SPSS, is there any issue in downloading that file? Everyone? Yes, is there any issue, everyone, in downloading that file? Can I, have you all downloaded the file? Am I audible? Yes, Sudhir ji, if you are listening to me, am I audible? Okay.
Yeah.
Fine, fine. So we will go with exploratory factor analysis. As I have said to you that factor analysis can be of two types. Remember all the time. One can be exploratory factor analysis and the second can be confirmatory factor analysis. So like EFA and CFA, these are two parts of factor analysis. Exploratory factor analysis can only be performed when there is no model, when there is no information available for the particular variables, when there is no possibility of adaptation of scale, when there is no possibility of rewording the items. In that case, there is always some issue that how many things can be combined together and can give a reflection to a construct. So I'm taking a study. For an example, there is a study where there is a confusion regarding the performance and the physical appearance of car, that how to measure. So what construct can be taken, and there was hardly any scale which was available in the market regarding this. So the researcher has conducted one study where customers are asked various questions on Likert scale regarding the engine size, horsepower, price, wheelbase, width, length, fuel capacity, and fuel efficiency. Right. So I will be just sharing with you the SPSS file. This file is already there into the system if you have downloaded the SPSS. So in the folder of SPSS 23, there is one folder. If I want to show you, like, if you really want to see that from where we can have the sample files, you can go to C folder just for your practice. Let me tell you. You can go to C folder, then program files, then you can go to IBM, SPSS, statistics, 23, samples, English, and then you can see that many sample files are there on which the practice can be done. So I have taken the file from here only to perform the analysis, that is car sales file. So that is the same file. Even if you want to practice on any of the file, you can take the sample from there. Right. So this is the data in which I have asked the customers regarding the price, engine, horsepower, and all this data. If you see, okay, anyone who can tell me whether this data is on nominal, ordinal, interval, or ratio? Anyone? Can anybody give me the answer? On what scale this data is being collected? Yes, Jacob. Thank you so much. Yes, it's on ratio. Wonderful. So ratio will be considered as a data collected on metric, first of all. So whenever the variables are on metric, even in that situation, we can go with EFA. Now, there are few things which we have to understand. Although EFA analysis can be directly done with the help of factor analysis, but before performing this EFA analysis or factor analysis, we will also see the correlation between the variables. Remember one thing, whenever we are about to perform EFA, there are some prerequisite, and one of the prerequisite is, you can even note it down, that all the variables should have multicollinearity issues. What is multicollinearity issue? Multicollinearity issue means there is a high amount of correlation between the variables. So all the variables should be having a high correlation with each other. So how we are going to justify that whether there is a collinearity issue in the variables or not? First of all, we will go to analyze. We will go to regression. We will go to linear regression. So let me just tell you how to do this. So the dependent variable is confirmed. I want to check all these variable impacts on sales, but I am not confirmed that which independent variable will be having what kind of construct. I'm not sure that which independent variable should be signified to what construct. So what is my dependent variable? Sales. What I will do, I will shift that sales independent. And then from price to engine size, horsepower, wheelbase, width, length, curb weight, and fuel efficiency and fuel capacity, I will keep on independent variable. We will go to statistics and we will click for collinearity diagnostic, because I want to know whether all the variables are highly correlated with each other or not. So I will be clicking on collinearity diagnostic, continue, and then I will click on OK. Yes. So these are the variables which I can see. This is the output. Now, what output is important from the perspective of understanding the collinearity? There is one table which is showing collinearity diagnostic. So there is one term which is called condition index. You can note it down again. We can see the value of condition index is 1, 5, 11, 17, 37, 43. So the threshold value or the thumb rule says that if the condition index value is more than 15, that means that there is a collinearity issue. And if the value is crossing 30, you can see that till they are reaching to the last one, the value is increased to 146, which is more than 30. So if the value is more than 30, that means 100% there is a collinearity issue and all the variables are correlated with each other. So before running EFA and before running exploratory factor analysis, we should always check the collinearity diagnostics with the help of regression. And if you are going to put this in your thesis or in research paper, especially performance during EFA, that is going to be very much justified. That okay, all the variables are having the highly correlation. There is a chance that whenever we are going to put the factor analysis, they will be combined under some constructs. They will be creating some kind of groupings. So that is the first thing that is to be all the time performed. Now, once we are able to see that there is a collinearity issue, we will go to analyze, dimension reduction, factor. So what I will do, so you will find the table like this. So what I will do, I will keep all those factors which I want to analyze under the variables. We will go to descriptive. KMO and Bartlett test is necessity which is to be performed. So if the p value is coming significant, that means what is the significance of KMO and Bartlett test? It means that we are good to go. All the items are highly correlated with each other and the tests are significant and we can go with factor analysis. So the sample size is good enough. The items are good enough and we can go with factor analysis. That is the meaning of performing KMO and Bartlett test. So we will click on KMO and Bartlett test. Extraction is okay. Eigenvalue is 1. We can go with Verimax rotation. And in the options, what I have kept that the value should be ignored if it is having a small coefficient of 0.4. What is the meaning of this one? If I'm writing here 0.5, so my analysis will not have the values 0.5 or below 0.5. It will not come in the factor analysis. So it will suppress all the small coefficients. So I'm just going to continue. And when I say OK, can you see that what is the KMO and Bartlett test is saying? There are two things which we are supposed to report. First thing is the direct value, which you can see here, 0.818. What is the significance of this? If this value is coming between 9 to 10, that means all the items are sufficient enough, the sample size is good enough, the internal consistency is high, and if the value is coming between 0.8 to zero point 0.9, it is good. 0.7 to zero point 0.8, near to good one. But if it is less than 0.5, then there is an issue, and we have to again go and see what kind of data collection we have done. So because the value here coming is 0.818, so my results are also significant. That means number of items, sample size is good enough, and we can continue with the factor analysis. Now that is the one thing which you are supposed to report, KMO and Bartlett test. The second thing which we are supposed to report in EFA is rotated component matrix. So if you can see how many components are created here, 2. So if you see price in 1000, engine size and horsepower, they are combined into one. Their value of correlation are very close to each other, 0.795, 0.925 and 0.924. So what we will do, we will keep these items under one construct. We will go to the literature and we will try to find out price, engine size and horsepower, under which construct we can put these things. And we can say that engine power is the one thing, which can define the horsepower, engine size and price in 1000. So I can create one construct that can be considered as a engine power and cost factor. That could be my one construct. So under my one construct, I can keep these 3 items now. And what can be my other construct? Wheelbase, width, length, curb weight, fuel capacity. Fuel efficiency I will not take because this is giving me the negative relativity. So I have to remove this. I will not be keeping this item in my study. So I will be taking wheelbase, width, length, curb weight and fuel capacity under the heading of physical dimension factors. So when I am going into the literature, I can see that width, length, curb weight, fuel capacity and wheelbase comes under the physical dimension factor. So I will be creating 2 construct here. One is engine power and cost, and the second one is physical dimensions. So before analyzing factor analysis, what we will do, the first thing is we will analyze the collinearity dimensions with the help of regression. And if there is a high collinearity, which we have seen, which can be justified based upon the condition index. Let me just show you again the output. This is the last time I am just explaining this. Then I'll go to the CFA. So what we will do, we will see the condition index. Always remember, we can report this thing in our thesis that the value of condition index is more than 30. So when it is more than 30, that means all the variables are having high collinearity. Then we will go with KMO and Bartlett test. KMO and Bartlett test is significant. We can go with factor analysis. And then we will show the rotation component matrix. These 3 are coming under one bracket. We will not take this one. It is again 0.442, which is less than 0.5. This is negative. So these 5 will be under one construct and these 3 will be under one construct. Likewise, I will be creating my 2 construct. Under one, there are 3 items and under the second one, there are 5 items. So is it clear to everyone?
Ma'am,
Yes.
can't we take 0.5 for two value because it's more than 0.5, right? In case
Which
of
one,
curve
ma'am?
weight.
Which one? Which one?
Component 2, when it comes in component 2, its curve weight, it is more than 0.5. That is 0.542.
So ma'am, we are taking it because
So that
in
under component 2, there are 4 items, if I'm not mistaken.
no, ma'am, no. I'm just sharing the screen to you. Please, just wait a minute. Just wait a minute. We have to see the results, ma'am, in correlation to the first factor also. If you see these three these are coming under the component 2, right, ma'am? But where the value is high, if you see the value is high here, 0.9, 0.7, and
Excuse
0.9.
me, madam.
Yes,
Excuse me,
sir.
madam. Your
Yes.
email is actually showing in the screen, as far as I can see.
The
What is
screen is
being
Your,
shown?
in
shows.
fact, your Gmail,
Okay,
your
okay,
Gmail
wait,
is
wait, wait,
your
wait, wait, wait. Sorry. Wait a minute. Yeah, is it okay now? Are you able to see the results?
Yes, ma'am. It's okay now.
Okay, fine. So, ma'am, when we are going to see these three are coming to the component which in literature review you will find that these three are more of talking about the engine power and cost factor. Whereas all these items are having the highly correlation value, which in literature you will go back and you will find that all these items can be correlated under one construct called physical dimensions. That is why we are not taking this one here, because 0.52 is having the higher value here in component 1. Is it clear, ma'am?
Yes, ma'am.
Yes, ma'am. Yes.
Okay. Thank you. So we will be running the EFA. Is it that I am able to make you understand why to run EFA? So when the variables are not confirmed, and generally EFAs are performed by those people who are like, scientists. They are going to find out something very new, which is like recently being happened. So even after COVID, if people want to write some papers upon the circumstances, the position, the responses, the kind of illness are being faced by the people, so at that time we can even refer to SARS, which has been happened few years back. But if something is not available even at that particular time, we will start talking to the people, we will be taking their reports. Okay, and all those report data, if I am able to get it on a ratio scale, I will try to see that what factors can be combined under one construct, and that is the value, that is the main significance of EFA. So if everything is available, scale is available, everything is available, we are not supposed to go with EFA. No need to run EFA. So I think I'm just going to stop it, and then I'm going to talk about the CFA second. Now, if you see that whenever we are running CFA is called confirmatory factor analysis. This is the main thing. Why we are saying it confirmatory? Because I want to confirm the model. I want to confirm that all the items are supporting to the construct, and every construct is different with each other. So if I am having 4 constructs, all those 4 constructs should be different with each other. and how much part of each construct is explained by all the items. For just to check that thing, we will be running confirmatory factor analysis. So when we are running confirmatory factor analysis, we are supposed to report these things: goodness of fit factors and badness of fit factors. So I'm just going to show you how to run this. We will be using the FDP sample site, right? So what is this data is talking about? There are 4 constructs. The first construct is called SSC. What is the meaning of SSC? Let me just tell you what I am going to justify with this model. What is this model all about it? There are 4 constructs. First of all, just understand which model I am going to check. What is the significance of that model? Okay, like see it here. So my model is, my dependent factor is sustainable supply chain management. This is my dependent factor. And I am having 3 independent factors, 1, 2, and 3. My first factor is data analytics with AI. That is my first construct, which is having 4 items. My second one is inventory handling. Inventory handling with AI, that is having 3 items. And my third construct is predictive techniques. That is also having 3 items. And these 3 independent variable, I want to check the impact of these 3 independent variables on the dependent variable SSC. So these are my independent variables and this is my dependent variable. So is this that the model is clear to everyone? Can I start working on CFA?
Yes.
Yes? Okay. So I have already provided you the sample size, this sample file. So what I have done initially, I have created these variables. DA means data analytics. There are 4 items. So I have write these DAQ1, DAQ2, DAQ3 and DAQ4. My second construct is inventory handling. So IH is inventory handling. And there are 3 items, Q1, Q2, Q3. Then predictive analysis, there are 3 items, Q1, Q2, Q3. And then the last one is SSC, sustainable supply chain. Again, this is having 3 questions, Q1, Q2 and Q3. So in SPSS, under the variable view, I can create those variables. So if I'm having one more variable, I can create like this, right? So I have just kept it like this. Then from the measurement, I can change them into a scale. It is not nominal. It is on the ratio scale. So I will be changing them from here. And this is not in my record, so I will delete this. Now I will save the file. I'll open the AMOS. I will create the new file. So, yes, this is the front page. This is the blank page on which we are going to create the CFA model, right? So CFA model is not checking the regression. It is simply checking whether the model is having the right number of items and every construct is different from each other or not. So how we are going to do this? You all can see this. This symbol can be used to draw a latent variable. I will be dragging this here. We'll create one. I can select it from this and I can get it duplicate 4 because I'm having 4 constructs. Now in first construct, I'm having 4 items. So I will keep this symbol here and I will click 4 times. 2, 3, 4. I am having 3 items here. 1, 2, 3. 3 items here. 1, 2, 3. And 3 items here. 1, 2, 3. If you go and see the slide, so how many items were here? 4 in data analytics, in inventory 3, in predictive analysis 3, and in SSC also there were 3 items. So that is why I have taken 4 here, 3 here, 3 and 3 here. Now, what I'll do, I will select all these and I will rotate these like this, like this, like this, and in that way, right? Now what we will do, we have to select the data, that to what data we are using into this. So we will go and we will click it here, select data. We'll click on file name. And we'll click on OK. Are you able to get it till here, everyone? What is happening? Yes?
Yes, ma'am.
Okay. Then what we will do, the file is already attached. So we will click on this file and this window will open. We will keep all those variables. We will drag and keep it here. This is the first item. This is the second item. This is the third item. And this is the fourth item. Now for the second construct, this is the first item. This is the second item. This is the third item. For the third construct, first, second, and third. And for the fourth one, this is the first item, second item, and third item. So once we are able to drag all the items into the construct, I can always write the name of the construct. What is the variable name? That was the first one. Data, or I can write in short, DA. So data analytics with AI. I can write here what was the second one. That was inventory handling. The third one is predictive technique. And the fourth one is sustainable supply chain. Now, there are some measurement error blocks. If you can see these round circles in CFA or in SEM, these round circles are helping in removing the measurement error, which is not possible to be removed in regression. So if you remember, I have told you yesterday the difference between regression and CFA. So in regression, we are unable to remove the measurement error, which is possible here to remove it. So what we will do, we will go to plugin and we will name all those unobserved variables. So if you can see, the names are given to all these measurement error. E means error. E1, E2, E3 and E4. Then to run CFA, we will go to plugin and we will draw the covariance. But before that, I have to select all the variables. Otherwise, what will happen? Only these two variables were selected. So these two covariance can only be created. So we will go here. We will click on it and we will select all variables. So all the constructs are turned into a blue color. So when all the constructs are turned into a blue color, that means all the constructs are selected. You go into plugin and draw covariance. Now, to make this diagram more beautiful, what I will do, I will change the rotation of these to be here. And now you can see that this is the CFA image that is being created. So what we will do, we will click here. If you see analyze properties. And before that, we will save this data too. So we are supposed to save the path. So what I will do, I will go to desktop. I will save this file as a sample CFA and I'll save it. So what is to be done? What analysis I'm doing? I will be seeing the generalized least square, maximum likelihood or generalized least square. So we will go with least square. Output, we will see squared multiple correlation, standard estimates. And that's all that we need to perform. We will click on analysis. So when your data is analyzed, you will be able to see the standardized and unstandardized estimates. And that can be seen with the help of this output. Can you see the output is generated? So this is the output. So what is to be seen? What is to be measured? We will go to variable summary and we can also see model fit. These are the reports that are to be reported in your PhD. We will go to model fit. So there are few things. If I want to tell you that, what is the first thing? Default model. What is the value of CMIN? CMIN is actually a value of somehow a chi-square test. So in CFA, it is assumed that the threshold value should be less than 5. So 3.414 is the very good value. That means your model is good. So the CMIN value should be less than 5, which you are supposed to report first. Now, what are other things which we are supposed to report in CFA? In goodness, the first one is chi-square test that I have told you, like less than 3 is good, but less than 5 is acceptable. So my value is 3.44. What is the value? 3.414. So that means my model is okay. So in few of the papers, it is mentioned that if the value of CMIN, which is the value of chi-square test, It should come less than 5. Now, there are some goodness of fit factors and badness of fit factors. What is the meaning of goodness of fit? Means what are those things which are good and we can accept in our model. So those good things which can be acceptable, that is going to be justified with CFI, GFI, TLI and NFI. Now, in your thesis, it is not mandatory to mention all these 4 index. We can mention maximum 2 out of 4, which is more than enough. So you find out on your reports that which is good enough to go and try to mention which is actually into the model. So for an example, if I see the CFI, what is the threshold value of CFI or GFI? For GFI, the threshold value is, it should be more than 0.9. So higher is it? It is considered to be a better fit. Now let's see what is the value of GFI here. Yes, the value in my model is 0.762. So it's not so good, but then also it is okay because it is more than 0.5. So generally, the model is to be considered in a very, very good position if the value of GFI is more than 0.9. And it is also said that if it is higher, it is to be considered as a better fit. So if my chi-square value or the CMIN value is coming to 3, because here it is 3.414. So if it is coming 3, then there is a possibility that the value of GFI can be more than 0.9 or close to 0.9. Now, what can be the other things that can be mentioned? For the badness of fit, we can mention RMSEA or RMR. So we will see where is RMSEA. It must be here. Yes, it's RMSEA, which is a goodness of factor. The value is coming to 0.136. So what is that is to be accepted? In RMSEA, that is the root mean square error of appropriation, that should be less than 0.08. So what is coming in my report? That is coming to like 0.136. It's pretty higher if we see that. So again, but I have to report what kind of model applications I am having. So if my model is not reporting so much good values, generally what we do, we go back and we have to see whether the sample size is correct or not, whether my data is normally distributed or not. So we can check the values of skewness and kurtosis. So when these values are not coming appropriately, the chances are that sample size is not sufficient enough or the data is not normally distributed. So just keep in mind one thing. In your thesis or in your paper, you are supposed to mention this diagram. This diagram is to be reported plus all the values of model fit. So CMIN value, GFI value, CFI value, RMR value, RMSEA value, all these values are to be informed because what all these things are doing, these things are checking 2 things which are very important. What is the advantage of doing the CFA? Actually, CFA is doing 2 kinds of analysis. One is called discriminant analysis. Are you with me? Are you all? Are you able to understand? Yes.
Yes, ma'am.
Okay. And the next one is convergent analysis. Actually, CFA helps in doing these two things. So convergent analysis means that how these items are being explaining to the construct and how much. So how much these items are explaining to a construct, that can be checked with the help of model fit and the value of goodness and badness of fit factors. But whenever you will run this convergent analysis on Smart PLS, this is again one more software, there are two things which you will see in your software. The one thing is AVE value. So this is called average variance extracted. This is AVE. And the second thing is CR, composite reliability. In Smart PLS, you will find these two things. If the AVE value is more than 0.5, it means these items are explaining more than 50% to a construct. If the value is 0.6, these items are explaining 60% of the construct. So it should be always more than 0.5, the AVE value. And what is composite reliability? Composite reliability checks basically the relationship between these items. They should be highly correlated with each other. So that is why it is considered that the value of Cronbach alpha should be always more than 0.6. So for an example, just to tell you how composite reliability works in convergent validity, for an example, I am measuring one construct called satisfaction. And there are three questions, three items. So satisfaction 1, this is the first item, satisfaction 2, second item, and satisfaction 3. And there are three respondents, first respondent, second respondent, and third respondent. So if the first respondent has given on a scale of 1 to 5, 5, 4, 1, 5, 4, 1, and 1, 2, 5. These are the responses for an example which are given. And if I am going to see that this on a scale of correlation, set 1, set 2, set 3, again set 1, I am going to see the correlation, set 2, set 3. So 1 is having high correlation with 1, 2 is having high correlation with 2, and 3 is having high correlation with 3. So remaining values could be 0.4, 0.5, and 0.6 if I am going to check the correlation. So these three are going to be the mirror value. These are three will be the mirror image, right? Because set 1 relationship with set 2 is what? Set 1 relationship with set 2 is 0.4. So again here is it's coming 0.4. So these three are the mirror image. So let me just show you once more if you are not able to get it clear. For an example, मैं दोबारा बता रही हूँ. I'm just telling you again. I am having one construct satisfaction and I want to check the reason behind the CR, how CR is being calculated. So we are having three items, satisfaction 1, satisfaction 2, and satisfaction 3. I am checking the correlation between all three. Satisfaction 1, satisfaction 2, and satisfaction 3. Now look at here. Satisfaction 1 is having satisfaction 1. What is the correlation? Absolute 1. 2 with 2, absolute 1. And 3 with 3 is absolute 1. Remaining, if the correlation is 0.4, 0.5 and 0.6. These are the mirror image, right? So what is the formula whenever we calculate the composite reliability? The formula is, we'll write the formula and understand how the Cronbach alpha is being created. The formula is that composite reliability is equal to K multiplied by R bar divided by 1 plus K minus 1 into R bar. Now, what is K here? K means number of items. And what is I bar? R bar is average inter-item correlation. Inter-item correlation. So if I calculate the value of R bar, what will be the value that will come? The value of R bar will be 0.4 plus 0.5 plus 0.6 divided by 3. So what will that come? 6, 10 and 5, 15. That means 1.5 divided by 3. That means it will come to 0.5. Is it? So the value of R bar is 0.5. Now putting that value into the formula, what is K? Number of items. So how many items are there? 3. So 3 into R bar, that is 0.5 divided by 1 plus K is 3 minus 1 into R bar, that is again 0.5. So it will come to 1.5 divided by 1 plus 2 into 0.5, it will come 1. So 1.5 divided by 2, the answer will be somehow come to 0.75. So when the Cronbach alpha value is 0.75 or composite reliability is 0.75, that means these 3 items are having a correlation of 0.4, 0.5 and 0.6. So even if one item is having the correlation less than 0.5, then also the Cronbach alpha value is pretty enough, 0.75. So I mean to say that whenever we are checking the value of CFA, in CFA, we generally see the goodness and badness of factors in AMOS. But whenever we are performing the same thing on Smart PLS, the convergent validity can be seen with the help of AVE and CR. And in AMOS, that can be checked with the help of goodness of factor, badness of factor, and model fit. So model fit should be generally less than 3, and if it is less than 5, it is okay, acceptable. Badness of factors we will calculate with the help of RMSCA or RMR, and goodness of factors we will see again with the help of CFI and GFI. Now the second thing is discriminant validity. In AMOS, this discriminant validity is generally combined with convergent. But in Smart PLS, we can calculate this with the help of MSV and AVE. So maximum, strategic variation which we are having, and average variance explained. These are the 2 things which are to be explained. So whenever I will take the next session on Smart PLS, I will be teaching you how to calculate these value of MSV and AVE. But at the time when we are doing this analysis on AMOS, in AMOS, the output can always be conducted in terms of model fit, goodness of factors and badness of factors. And this is the diagram that is being to be mentioned. Is there any doubt till now? Anyone?
Ma'am, actually, we do it through Excel, right? Whenever we are doing AMOS, I think I've attended one workshop where they do a discriminant validity in Excel, and they then
Ma'am, there is always one plugin.
yeah, ma'am.
Yes.
Please, can you
That I know that, but
can you tell us, ma'am?
I can tell you, no issues. We can do it with the help of plugin also, right? But if that plugin is not available, and ma'am, if you see the paper written by, I will be giving you few references like Ramisa et al. 1994. If you go with these references, they said that AVE and MSV values are to be reported whenever we are having the scale which is more on a formative as compared to reflective. Otherwise, AVE, MSV, if the plugin is available, we can always go with that. Otherwise, for the CFA, there are three things which are very, very important. One, the model fit, and the remaining two things are like goodness of fit factors and badness of fit factors. Otherwise, I don't have that plugin right now, but I will add that plugin. I will create a short video of that. When we will run that plugin, we can also get the value of MSV and AVE.
Yeah, ma'am.
Yes, ma'am.
So it's not important that we have
No,
to
no. It's not important. But yes, whenever we are doing it with the smart PLS, we need it.
Okay.
Otherwise, I will tell you one repository through which those plugins can be downloaded, and we can add on those plugins here. But I have told you the meaning of it. So
Yes.
in the convergent validity, what are the two things which you are supposed to mention? AVE and CR. And in discriminant validity, we are supposed to mention two things, ASV and AVE. So these are the four values which are to be reported. Okay, ma'am, fine?
Yes, ma'am.
Okay. Now we will go with regression. I will create a short video today itself to add this plugin, and you can add that plugin and we can have the value of MSV and AVE also. No issues into that.
Yeah, ma'am. Even
Now
the
we will,
PPT you will give us, right?
yes, I will share that.
Okay.
Now I will be running the regression now. So to have the regression, we will be creating the same model here again. So now my model is having three independent variables. And one dependent variable. So it is having 4 items, 3 items, 3 items, and 3 items. We will save the file again. We will have the list. We'll add on these variables. If we do not want to write the names, although we should write here, we can write it. We can go to plugin, name all the unobserved variables. And in regression, we will use this arrow to show the relationship. We'll save this file. Okay. So what we will do here, this is the SEM model in which we can see that there are 3 independent variables and 1 is dependent variable. We will see what analysis we require to be performed. So generally we see with squared multiple correlation. And we will run this. Yes. So results are generated. We will see the output. Now, first of all, what we are supposed to report here is the regression weight. So the regression weight, if you could see that, what you could see that all results are coming significant. That means the value which is coming here, we have taken it on a 95% confidence interval level, and it should be like if it is less than 0.05. So we have kept the value of P is 0.05. So less than 0.05, that means null hypothesis is rejected and alternative hypothesis is accepted. That means data analytics with AI is having its relationship with SSC. So what can be my first hypothesis? Let me just go back. What was my first hypothesis? That there is a significant relationship between data analytics with AI and sustainable supply chain management. There is a significant relationship with inventory handling with AI and sustainable supply chain management. And there is a significant relationship between predictive analysis with AI and sustainable supply chain management. So if you could see this, the P value is coming almost significant except this one. So we can go with these regression weight. There are 3 things which we can mention all the time. One is the regression weight. Second is the variance is not to be reported, like squared multiple correlation value. Now, what is this squared multiple correlation value is explaining to that if I increase the third item by 0.62, what will be the impact on sustainable supply chain management? So when I will make some changes into the independent variable, what will be the impact on the construct? So squared multiple correlation simply tells you the meaning of what is the impact of all these items onto the construct, how much part of each individual item is being explained towards the construct. So generally we mention these 2 things. One is the p-value. So if it is less than 0.05, that means my null hypothesis is rejected and alternative hypothesis is accepted. And the second thing which we can mention here is squared multiple correlation. So whenever we are going with this kind of analysis, we are supposed to show this diagram. But there is one more thing as a prerequisite, we can check it. Whenever you are running CFA and SEM, there are few requisites which we are supposed to mention in our thesis. We can go to the SPSS file, we can go with data view, we can go with analyze, descriptive analysis. First of all, we will be checking the frequencies. That we will do before running the CFA and SEM. So if we generally what we do, these are some prerequisites which is to be performed earlier. But if we are not mentioning this thing, and if the results are not coming appropriately, then again we will go and check whether my data is normally distributed, what is the value of skewness and kurtosis. So it's better before running CFA and SEM and before running factor analysis, you go and you should check the value of skewness and kurtosis. So we will click on skewness and kurtosis, continue. And if we want any kind of chart, we can again go with that. If you really want to put these chart, bar chart or pie chart in your thesis, and then we will click on OK. What you can see, the skewness and kurtosis value, the threshold value, or in some of the research paper, it is mentioned that it should come between +3 to -3. If the value is coming of skewness and kurtosis is +3 to -3, we can always say that yes, my data is coming under normal distribution. And second thing which I have told you yesterday, that to run analysis on AMOS, there should be at least a sample set of 200. Or as per the thumb rule, that whatever number of items we are having, it should be multiplied by 10. So if you see in our study, how many items are there? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 into 10, at least 130 should be the sample size. And there are many references which are available. I have also added on few of the references in my PPT. So before running CFA and SEM, you can always go to see the frequency analysis, and then you can also go with the descriptive analysis too. So in descriptive analysis, you can generally see that if there is any missing value, if you see this, what is the minimum value which is given by the respondent? In few of the case, the minimum value is even, not given by the respondent is 1. And the maximum value is given by everyone is 5. So there is no missing value. All 131 responses are being recorded. The minimum is 1, maximum is 5, 3 and 5. This is the mean and this is the deviation. So all this kind of descriptive analysis can also be added on before going with CFA and SEM. So that we can run. We can start with exploratory factor analysis. Let me just review once again. We can always start with exploratory factor analysis. If I am unable to find out the factors and constructs, if I am very much aware that the variables are good enough, literature is supporting, I am able to adapt the scale, I can go with CFA. And CFA, 3 things are very important. But if you really want to show the discriminant and the convergent analysis, then there is a plugin. We can add on that plugin and we can also show the value of AVE and MSV. That's very easy to do it. So we will be doing it with the help of goodness of fit, badness of it. This can be measured with the help of CFI, GFI, any 2 variables you can take on. So any 2 variables can be taken to justify. These are the threshold values. If the values of all those analysis which you have done is coming according to this, you can say that your model is perfect. So before having SEM, you should always run CFA. So because SEM is a combination of regression and path analysis, we will be reporting generally 3 values, like the p value is 1 and the second one is squared correlation. What is p value? P value is the significance value. If it is coming less than 0.05, it means that my alternative hypothesis is accepted and there is a relationship, there is an impact, whatever hypothesis we have framed. And in squared correlation, it is being explained that if you explain in item by 0.6%, 0.6, what will be the change that will take place on the dependent variable? So these are the maximum values that can be reported by doing EFA, CFA, and SEM. Now, please ask me the questions. Yes,
Ma'am, I have a query.
yes, please.
Ma'am, when we are drawing this, if you look at the major journal papers, we will not have error term in the second order construct.
Okay.
Like we have it only in the first order construct, that's the measurement model. Now you have shown us with error terms. So how do we remove those? And
Ma'am, you are not required to remove those error drums, ma'am, when we are running SEM. Pooja, ma'am.
yes,
Why?
ma'am.
I have told you, like yesterday also, SEM is not only running the regression, it also includes the path analysis.
Hmm.
And there is always a difference by running the simple regression. So whenever we are having, this kind of model, even if we are having the mediators and moderators, we can follow the results with the error drum all the time, because as soon as I have run regression on this, SEM analysis on this, they are automatically able to monitor those measurement error and remove it.
And you didn't show us the weights, ma'am. Weights, like we see the weights, right? What button to press to see the weights in the model? I think,
Okay.
yeah.
Okay, let
ma'am.
me just show you.
Yeah, ma'am. And also, ma'am, if we have a mediator, how do we go ahead? If you put one mediator and show us.
Ma'am, are you able to see this? Is it
No,
visible
ma'am.
to you now?
No, ma'am.
Okay, wait. Let me just show you, please. Pooja ma'am, is it visible to you now, all the way?
Yes, ma'am. Yes, ma'am.
Okay, so your query is regarding the...
Yeah, now I can see the weights, but before
Yes.
this, we couldn't see the weights.
No, what we have to do, we have to click on this red button.
Okay.
Okay, there.
Yeah.
At the above side, there is one red button. As soon as you will click on this,
Okay, ma'am.
there are 2 kinds of weights which are visible, unstandard and standard.
Okay.
So this. So by,
So we have to press unstandard weights.
ma'am, yes, these are unstandard estimates and these are standard estimates. So
Okay.
we can always mention the standard estimates whenever we are supposed to put this into a thesis. So generally we can take like a screenshot of this, we can paste it, and what we are supposed to mention the p values and the squared correlation. That is more important.
Okay, ma'am.
These are the 2 things which are most important.
Now, if there is a mediator, ma'am.
Just give me 2 minutes. Give me 2 minutes. Just give me 2 minutes. Let me take any example. If I can have this example in my files, is that I was not having. Ma'am, have you ever run the bootstrap? Are you able to understand the bootstrapping? Are you all? Do you all know that? No. Okay.
No, ma'am. Don't recall it.
Actually, again, okay. Okay, I will be just taking one example, and actually in Smart PLS we are having one very good function which is called like full mediation, partial mediation, or half mediation. So generally, to check the impact of mediation and moderation, it's very good to use Smart PLS. But let me just make you understand first that how do we decide that what is a mediator or what is a moderator, because that's the major part in which the confusion is basically faced. Let me just tell you. Suppose there are three constructs. One is innovativeness, which in short can be called as a IV. One is gender, for an example, and one is like trust. So this is the relationship. Gender innovativeness is impacting on gender. This is on trust, and trust is on again gender. Now, ma'am, can you give me the answer? Like all of you can give me one answer that is there any logical impact of trust on gender? Can we have a logical effect of trust on gender, that trust ka impact gender pe? That
No.
females are more trustworthy?
No, ma'am.
No. So if there is no impact, for an example, if there is no impact of trust on gender, which I am considering as I am confused whether it should be mediation or moderation. When I am having a confusion, whether it is a mediation or moderation. So when there is no relationship between trust and gender, then it should always be a moderator. And when there is an impact of trust on gender, for an example, anything which you are taking that trust on satisfaction. So can we see that there is an impact of trust on satisfaction? Yes. Trust builds satisfaction. So then we can say that it could be as a mediator. So ma'am, in Smart PLS, there is a full possibility. Again, I will create a short video of this because mediation moderation was not having in this. In AMOS, there is a possibility, but we can only check with the help of regression. What we can do, we can again put this as one of the variable in a linear regression, and we can check that whether there is an impact of trust on the satisfaction or not. If it is not, we can say that it is a moderator. If it is there, we can say it is mediator. But ma'am, in Smart PLS, I have taken this workshop just 1 month back on Smart PLS, where I have shown the partial, full, and no impact of mediation and moderation. तो या तो आप उसको भी रेफर कर सकते हैं, अदरवाइज आई विल क्रिएट अ शॉर्ट वीडियो ऑन स्मार्ट पीएलएस. तो मैं एक प्लगइन का और इसका एक शॉर्ट वीडियो क्रिएट करके आई विल पुट इट इन द ग्रुप, so it will be easy for you to understand on smart PLS. Otherwise,
now what you said, so if we were talking of the same 3 variables that you have already done, so uske beech mein ek we can bring satisfaction, so I have to measure first these 3 variables on satisfaction as a
no. First of all, you will go with running CFA. First of all, if all 3 constructs are having, all the items are supporting to the construct, all the constructs are different with each other, my model is good enough, I will go with SEM. I will first all check the simple model, all the independent variable with dependent variable first, my first process. In the second process, because my hypotheses are going to be the different one. my first hypothesis can be that trust is having relationship with satisfaction. Or my second hypothesis can be like innovativeness is having impact on satisfaction. Then I have to create one more hypothesis that trust mediates the relationship between innovativeness and satisfaction.
Okay, ma'am.
So I have to first check whether it is a mediator or moderator, and then I will be preparing one hypothesis that trust mediates between innovativeness or satisfaction, or trust moderates between innovativeness or satisfaction. So I will just, maybe by tomorrow morning, I will create a short video and on Smart PLS run that analysis. It will be very, very helpful for you to put it in your paper, because sometimes what happens, the mediation can also have a partial impact.
Yes.
There is no full impact. So that partial impact cannot be checked with the help of AMOS. AMOS is unable to check that. In Smart PLS, we can do that.
So are journals accepting? Because some of the journals don't accept Smart PLS, ma'am.
Ma'am, in almost nowadays, you check the Emerald papers, SCI, ESCI. Recently, my one of the paper I'll share in the group is being selected into ESCI.
Okay.
So it's like, it was a Wiley journal. That was, the journal name is Customer Review, sort of that. Economic and Customer Review. It is a Wiley journal. It took almost 1.5 years. 1.5 साल लगा मुझे उस पेपर के accept, but they accept the Smart PLS, but you have to be able to fulfill the prerequisites. There are few requisites.
Okay.
So if I have to show even that I am unable to, show the impact of mediation on AMOS, that is why one of the hypotheses, just to prove one of the hypotheses, I have chosen Smart PLS. Although Smart PLS should only always be run for the PLS, partial least square. That means the questionnaire should be on the formative. But there are many papers nowadays, you can check it on, who are supporting that even if the questionnaire is prepared on reflective, you can go the analysis with Smart PLS. Whatever analysis you are doing, just take a reference from the papers which are published. Otherwise, requisites are completely different. For reflective one, go with AMOS. For formative one, go with Smart PLS. So these are the differences.
Yes, ma'am.
Whenever the students are coming to me, ki, ma'am, my model is not coming properly, what to do? It is not coming free. So we go back, we make some changes into the data collected, we remove some of the items, because the data is not normally distributed. AMOS will never give you the result.
Yeah, ma'am. That's the problem.
Smart PLS is one tool which will always help you with small data collection, and even when data is not normally distributed. So we can easily go with Smart PLS with a small sample size and with no normal distributed data.
Okay, thank you.
So any other thing, anyone, that we are just about to wind up the session? If you have anything to ask, I will be sharing my email ID and phone number. If you have anything to ask related to this workshop or anything else related to writing a research paper, or I'll share my papers also. Like I have more than 11 papers which are Scopus indexed, 11, 12 good papers. You can see the analysis part from there if you want to take any reference. Okay, so thank you so much. Thank you so much, everyone. I think I should wind up the session now.
Yeah, ma'am. Thank you. Thanks a lot.
Thank you, Pooja. Thank you, ma'am. Thank you.
Thank you, ma'am.
Okay, thank you. Thank you.
Thank you, ma'am. Thank you.
Thank you, ma'am. Thank you.